Hello class, this is Mr. Buford again. I'm going to provide you some comments on the exit ticket we took on quadratic function factoring when a is equal to 1. Just thought I'd provide some comments for you. If you have some detailed questions about the exit ticket and like to discuss, just let me know. But I'm just going to briefly go over the questions and provide some commentary. So the first question is, factoring a quadratic function primarily involves transforming a binomial expression into the product of two trinomial expressions, primarily for the purpose of modeling quadratic functions. Well, this statement is false from the start, right? Because a quadratic function is not a binomial. A quadratic function is a trinomial. So I was testing to see if you remembered our discussion on that. A quadratic function is a trinomial that we're trying to break down into the product of two binomials. So this statement basically starts off saying everything backwards. So the true answer for this is false on both accounts. Alrighty, let's go on to number 2. What do we factor why do we factor quadratic functions? What is the ultimate purpose? Well, remember before we started doing quadratic functions, we were doing modeling of quadratic functions where we would model real world events. And right before we started the section on factoring, we had some examples of modeling where we would have a specific value of a quadratic function that we were that was our goal or that we wanted to achieve. For example, we were looking for if a company wanted to get a certain number of revenue. Remember, we had the record producer, and he knew that he wanted to get I don't know what it was, $600 million in record revenue, and he knew that we had designed him a quadratic function that would allow him to, depending on the number of bad words that were in the song or rap, he would make a certain amount of money. And so if he had a specific amount of money that he wanted to get, or she wanted to get, like 600 million, what is the specific number of bad words that are required to allow him to get that precise revenue? Well, remember what we had to do to find out what those number of bad words were. We had to, like, by trial and error, we had to keep substituting in different values of bad words to see if that would give us precisely the amount of revenue that the record producer was looking for. And in this particular case, I think the number of bad words were like 35 or 70, depending on the number, depending on what the record sales were. But in the real world, the number of choices would have been much larger than 35 or 78. We would have had to plug in maybe 1,000 or maybe 1,000,000 different choices to find the exact number that would allow the business person to find what they were looking for. Well, instead of plugging in different values into the quadratic function to try to find out just where the record producer would get the sales that they need, what we could do is plug in the value that the record producer is looking for, say 390 million or 690 million. Take that number, plug it right into the quadratic equation, and then we could use factoring to solve precisely for what that number of bad words were, instead of plugging in different values into the equation and trying to come at that value by trial and error. We could have just solved for it directly using factoring. And so that's the ultimate purpose of factoring, is to be able to directly solve a quadratic function and find the value directly, instead of having to do it by trial and error. Because in the real world, it could have taken days, weeks, months trying to find out what that precise value is. While if we take the number that the decision maker is looking for, plug that right into our equation, and then use factoring to solve directly for it, we could find the answer almost instantaneously. So the answer to this is a mathematical method for finding solutions to the quadratic equation. That's the answer. We want to be able to use factoring to make the process of finding solutions to quadratic equations easier. Okay, so let's move on down to number 3. All right, and here we have our quadratic function x squared plus bx plus c equals the product of x plus g times x plus h, and it says which expression is true. And we know from working in this case, when a is equal to 1, we know what must be true from our notes is that c must equal g times h, or b must equal to g plus h. And so when we look at our options here, nowhere do we see c equal to g times h, and nowhere do we see b equal to g plus h. Okay, so our answer would be none of the above. Okay, again, that's something where you have to look at your notes, and if you actually did the classwork, every time we did a problem, these two criteria were repeated, so that you would be able to get that in your mind, that in order to find this g and h that will break this quadratic function into two binomials, the formulas for finding gh is c should be equal to g times h, not g plus h, and then b should equal g plus h. So in this case, the answer would be none of the above. If we come down to 4, again, 4 similar to 3. If we know that a is equal to 1, and we're trying to take our quadratic function and break it into two binomials, none of these expressions are true except for this one. A is equal to 1. In order for all of this to be true, a has to be equal to 1. If a is not equal to 1, then this is not true. We have to change this equation around. So the answer here is a equals 1. And let's go to our last two. Here we're basically just asking you to factor this quadratic function, x squared minus 3x plus 108. And none of these are the solution, Basically, the solution would look very similar to this. It would be x minus 12 and x plus 9. Because you see here the b term is a minus 3x. So if x were a minus 12 and b were a plus 9, you would get that minus 3x there when you multiply these together. Okay? And so the answer is none of the above. And finally, we have the quadratic function y equals x squared minus 60x minus 70 represents the weight loss in pounds if you stick to your new diet, and x represents the number of days you need to stay on the diet to lose your desired weight. If you want to lose 50 pounds, what is the quickest way to solve for x and find the number of days that you need to stay on the diet? Number 1, put quadratic equation in a calculator or in spreadsheet and try different values of x until the quadratic function equals 50. Okay, that's one. The other solution would be to set y equals to 50 and solve for x. Factor the resulting equation and find out what value of x makes this equation true. Then finally, both of the answers above are ridiculous. Neither are true. Actually, the second answer is true. This is what we were discussing previously. If you have a function that models the real world, and in this case y equals pounds lost, that's what you want to achieve. And if you know what you want, you know what value goes in here, you can actually plug 50, substitute 50 for y, and then bring 50 on the other side of this equation. Then you can solve for x using factoring, and that would allow you to find the number of days directly instead of using the trial and error method suggested in part 1, where you keep sticking in different values of x in this equation until y equals 50. A quicker way is to just put 50 here and then solve for x, and you solve for x by factoring, and that way you would be able to solve it quicker. Okay, so that's those are the answers for the exit ticket. Hopefully the commentary that I provided with the answers helped to increase your understanding. If there's something that you did not understand, please let me know, email me, or just call me in class and I'll come by and discuss it with you. Alrighty. Look forward to seeing you soon, and take care.